Hello students. So after when Planck put his quantum theory, which states that light radiation travel in the form of discrete photon, Einstein in 1905 used that Planck's quantum theory, and on the basis of that Einstein explained photoelectric effect and gave his theory for photoelectric effect on the basis of Planck's quantum theory. So Einstein's theory of photoelectric effect is based on Planck's quantum theory, which states that light travel in form of discrete photons. So this is the basis of Einstein's theory. So Einstein in his theory consider this fact, and the photon that we are considering is of light, have energy h nu. If the frequency of light is nu, then the energy of photon is given by h nu, where h is the Planck's constant and nu is the frequency of that light radiation. So the main points that Einstein put forward in his theory of photoelectric effect are: the first point was photoelectric emission is because of the interaction of two particles. The one is photon, that is of incident radiation, and the other one is the electron, which is of that photosensitive metal. So the first point of Einstein theory of photoelectric effect is that this photoelectric emission take place or happen because of interaction between, now the two particles in between this interaction happen is, first is photon. Now this photon is of incident radiation, and the other particle is electron, which is of that photosensitive metal. So this is the first point of Einstein's theory of photoelectric effect. After it, the second point is the free electrons that are present. These electrons, the free electrons that are present within the metal, they are bound because of some forces on the surface, and the minimum energy that is required to liberate them or to free them from that metal surface is called work function of that metal. So the second point is the free electrons of metal are bound to the metal surface due to some forces, and the minimum amount of energy required to make them free from that surface, or we can say required to liberate them, is called work function, and we denote it by W naught. This is work function. Work function is the minimum energy required by the electron to show photoelectric emission or photoelectric effect, right? Now the third point is each photon that collide with the electron present in the photosensitive metal or interact with that metal, then each photon interact with one electron only, and it interacts such that the energy of photon, means h nu, which is the energy of photon, it get divided into two parts, or we can say that electron use the energy of incident photon for two purposes. First one, that is a part of energy is used by the electron to get liberated from the metal surface, and that energy is equal to the work function, and the remaining energy is used as a second part which gives the kinetic energy to the electron, and because of that those photoelectron move away from the metal surface. So we can write the third point as, third point states that each photon interact with one electron only, means one photon cannot interact with more than one electron, it will give its whole energy to single electron only. This one photon cannot interact with more than one electron, so each photon interact with one electron only. Now it interacts such that the energy of photon, that is h nu, the energy h nu of photon, this energy is used in two parts by the, this energy is used in two parts by the electrons, the free electrons of metal. The first part is the energy is used in liberating the electron, so a part of it is used to liberate electron from metal surface, and that energy is actually equal to the work function, so we write it as W naught. This energy is equal to the work function, which is the minimum energy required by the electron to just come out of the metal surface. The remaining part of the energy, remaining part is used in the form of kinetic energy of that electron, and that ejected electron travel because of that kinetic energy. We can also show it diagrammatically. So if this is the metal surface, right, this is the metal plate or metal surface which is photosensitive, and here is some bound electron. If we incident a photon over it, now this is a photon of energy h nu, and this electron we have is the bounded electron, and for it there exists, this is bounded electron, for this bounded electron there exists a kind of potential barrier on this metal surface which this electron has to overcome to come out of this metal surface, and the energy needed by this electron to overcome this surface is equal to the work function of that metal. So the energy h nu that we are imparting it by the help of photon get divided into two sections. A part of it which is equal to W naught is used by this electron to come out of this surface like this, so by using W naught energy it comes out. Now the remaining part of the energy will work as the kinetic energy of this electron, kinetic energy of photoelectron. So from this bounded state this electron use the amount of energy that is equal to the work function W naught to come out of the metal surface, and after that the remaining part is converted or is imparted as the kinetic energy to that electron. The last point that Einstein theory has is that very small amount of photons, approximately about 1% or even less than that, whose energies are more than W naught, are capable of ejecting the photoelectrons away from the metal surface. Otherwise, if the energy is equal to W naught, electron will come above the metal surface and stay there, and if its energy is more than W naught, only then kinetic energy is imparted to that photoelectron. So according to Einstein's experimental readings and observations, he observed that and stated that very few photons are there, right. So fourth point for Einstein's theory is, out of all the incident photons, very few photons, and the number is even less than 1%. Now these are those photons whose energy is more than W naught, that is work function, are capable of ejecting electrons. So these are all the points. That the first thing, photoelectric emission take place by the interaction of two particles. First is photon, second is electron of metal. Now the free electron of metal are bound to the metal because of some kind of force over the surface, and to overcome that force a minimum amount of energy is needed, and that amount is called work function W naught. Now each photon will interact with only one electron only, and the energy of that photon is used for two purposes. First purpose, to liberate the electron for metal surface, and that much energy that is used is equal to the work function. Now the remaining part of energy is used in the form of kinetic energy, and a very few photons are there whose energy is more than W naught. Only those photons are capable of ejecting electrons. Now considering all these points and applying the conservation of energy, so we are applying conservation of energy of incident photon, that we know is h nu, right? The energy of incident photon, this energy is used for two purposes. First purpose is to eject the metal from its surface, and that part of energy is equal to the work function, plus the second purpose, the remaining part, is used in the form of kinetic energy. So it is equal to the maximum kinetic energy that can be given to that photoelectron. So it is equal to maximum kinetic energy of photoelectron as per the conservation of energy. So we can write this equation as h nu is equal to W naught plus half m v max square, right? Kinetic energy will be maximum if velocity will be, or speed will be, maximum, because mass of the electron is same, that we can't change. So we can write half m v max square is equal to h nu minus W naught, and this is actually kinetic energy, maximum kinetic energy is equal to h nu minus W naught, and this energy is possessed by the fastest moving electron that we get. Okay, so this energy is the energy of fastest moving electron. Now the second thing that we have, let it be question number 1. The second thing that we have is W naught is equal to h nu naught, where nu naught is equal to threshold frequency, right? So threshold frequency is that much frequency. At that frequency we start getting photoelectric emission, means electron start coming out of the surface, and the energy corresponding to that is called the minimum energy required for photoelectric emission, that is equal to the work function. So we can also write equation 1 as Ke max is equal to half m V max square is equal to h nu minus h nu naught, and it can also be written as h into nu minus nu naught. So this is the main equation that we use further, and this equation is called Einstein's photoelectric equation. Okay, so this equation is called, actually equation 1 and 2 both, because these are the same equations, only we just put the value of W naught here. These equation 1 and 2 are called Einstein's photoelectric equations. So this was the theory of Einstein for photoelectric effect. Now after this he used this theory to explain the laws of photoelectric effect also. So we are going to explain laws of photoelectric effect on the basis of Einstein's theory. So now we are going to explain laws of photoelectric effect using Einstein's theory, and the first law we have is the law of effect of intensity, in which we explain the effect of intensity. So the first thing that we are going to explain is effect of intensity over photoelectric emission or photoelectric effect. So we are going to explain explanation for effect of intensity. Now intensity means the number of photons that are striking the metal surface per unit time, right? So if we say we are increasing the intensity, we mean that we are increasing the number of photons that strike the metal surface per unit time. So by intensity we mean number of photons striking metal surface per unit time. So if we increase this intensity, if we increase intensity, that means we are increasing the number of photons that are striking metal surface per unit time, and as the number of photons increase, as we know that each photon get interact with each electron, so this interaction, the number of collision between photons and electron will increase. There will be more interaction between the photons and electrons, and more number of electrons get ejected as photoelectrons. So if the intensity increase, that means the number of photons increase. So because of the increase in number of photons, number of photoelectrons will increase with the increase of this intensity. So this is the conclusion, that if we increase the intensity, that means we are increasing the number of photons, and if the number of photons increase, since each photon interact with each one electron, so the number of photons will cause more number of interaction with electrons, right? So more electrons will be interacted by the photons. Because of that, we will get more number of photoelectrons. Now the second thing is the explanation of threshold frequency. If threshold frequency is nu naught and the incident frequency of our radiation is nu, so if we assume that nu is less than nu naught, that means the frequency of incident radiation is less than the threshold frequency. So the kinetic energy of photoelectrons will become negative as per the Einstein's photoelectric equation. Einstein's photoelectric equation states that Kmax is equal to h nu minus nu naught, and if nu is less than nu naught, that means this kinetic energy become negative, which has no significance, right? So there is no physical meaning or no physical significance of negative energy. That's why this possibility is overruled. This is contradictory, and so photoelectric emission doesn't happen below the threshold frequency nu naught. For photoelectric emission to be happen, kinetic energy should be positive or zero, and in that case nu is either equal to 0 or greater, nu is either equal to nu naught or greater than nu naught. Only then the photoelectric emission takes place. So threshold frequency refers to the minimum frequency below which there is no photoelectric effect can be observed, no photoelectric effect happen. So this can be explained by Einstein's theory or Einstein's photoelectric equation. As per that equation, kinetic energy become negative for this condition, which has no physical meaning. So we states that for photoelectric effect to be happen, nu should be greater than nu naught. Now the third thing that we have to explain is the explanation of kinetic energy itself. Now for kinetic energy, if we take frequency more than threshold frequency, then in that case electrons will be ejected from the metal surface and they will have some kinetic energy to travel, and they get that energy or that kinetic energy to travel from the incident radiation or the incident photon. So as we increase h nu, w naught is fixed. That increased amount of energy will go to the part half mv max square, that is kinetic energy, maximum kinetic energy. As we know that the energy of incident photon is used for two purposes. Now the value of w naught is fixed. If we increase this value, this energy of incident radiation, by increasing the frequency, the value of that increase in energy will ultimately get to the kinetic energy or the maximum kinetic energy. That means if incident photon has high energy, we will get more maximum kinetic energy value. That means maximum kinetic energy, which is equal to half m Vmax square, is proportional to nu. Although if we talk about intensity, now intensity is the number of photons only, it has no relation with the kinetic energy. If we increase the intensity, there will be no effect on the kinetic energy. In that case, we can say that the maximum kinetic energy of the photoelectron is independent of intensity. So maximum kinetic energy depends directly or linearly on the frequency of incident radiation, while it is independent of intensity of incident radiation. This is the third one. Now the fourth one is the time lag. The fourth law states that the process of photoelectric effect is instantaneous. So to prove this using Einstein's theory, we can say that photoelectric emission takes place because of the collision between photon and an electron, and the collision that happened there is elastic collision. So photoelectric effect is a result of an elastic collision between incident photon and free electron of metal. Now the process of transfer of energy, during this collision the transfer of energy take place, and this process of transfer of energy is a single time event, right? This happen as a single event in which the transfer of energy take place in one lump as a one packet instead of continuous absorption of energy. Means there is no continuous absorption of energy, but the transfer of energy that happen here, it takes place, this transfer of energy takes place in one lump instead of continuous transfer. So that's why the process is very fast and there is no time lag between the incidence of photon and emission of photoelectron. जैसे ही that photon hit the electron, it just transfer its whole energy to that electron and electron starts showing the phenomena. So the process is instantaneous. That's why we call photoelectric effect as an instantaneous process. Now after the explanation of laws of photoelectric effect, Einstein's theory also help us to find the value of Planck's constant and work function graphically. So by using Einstein's theory of photoelectric effect, now we are going to find the value of Planck's constant and work function. So according to Einstein's photoelectric equation, we know that the maximum kinetic energy can be written as h nu minus w naught. Now if we have V naught, if V naught is the stopping potential, that means this much potential is needed to stop the fastest moving electron. So in that case the maximum kinetic energy will be equal to EV naught, right? The maximum kinetic energy should be equal to EV naught. Only then we can stop that fastest moving electron by applying this much potential. So by equating these two values, we get EV naught is equal to h nu minus w naught, where w naught is the work function, and V naught is equal to h upon E nu minus w naught upon E. Now if we plot a graph between the frequency and this stopping potential, so we take frequency on x axis and stopping potential on y axis, then the equation resembles as equation of a straight line. Y is equal to mx plus c, where the x coordinate represent frequency, y coordinate represent stopping potential, m is the slope of the graph. So slope of this graph is h upon e and c is some constant. So we can read the value of threshold frequency nu naught from the graph. Now the slope of this graph is equal to, the slope here is h upon e, and to find this slope we have to take 2 points on the graph. Let the 2 points be a and b like this. To find the slope we take 2 points on this graph and draw normals to them. Let this angle be theta. Okay, we have considered the angle ABC be theta. Then the slope of this graph can be given as the tangent of this value theta, tangent of the angle made by the line with the horizontal or with the x-axis. This is x, this is y. So the slope is equal to h upon e, and it is equal to tangent of theta. Now from the triangle ABC we can give tan theta is equal to, this tan theta is equal to perpendicular upon base, that means AC upon BC. So h upon e is equal to AC over BC, or we can write Planck constant as E into AC over BC, or E into slope of the V naught new graph. So if we know the slope, by multiplying that slope with E, we can find the value of Planck's constant. So Planck's constant can be determined by taking the product of E, that is electronic charge, with the slope of the given graph, right? Now the intercept of this line in the graph, right, this intercept on vertical axis of the graph, this represent by the factor minus w naught over e, because this c is actually the constant which represent intercept, and its value is equal to minus w naught over e. So intercept on vertical axis, that is c, is equal to minus w naught over e. So by reading the value of that intercept on the graph, if you find the magnitude of the intercept, we can find w naught also. Okay, so we can write w naught is equal to e into, we are leaving this negative sign because we consider the magnitude only, e into magnitude of intercept on vertical axis. So this is how we can find the work function, this is how we can find the Planck's constant, by reading this graph and using kinetic energy value by Einstein's photoelectric equation. Using Einstein's photoelectric equation and substituting the values from graph, we can find the value of both Planck's constant and work function using these relations. This is how it can be done. So that's all for the video. For further video, stay tuned and keep studying. Thank you.